All right. So does anybody know what mechanical advantage is?
No. Force.
Something about mechanical?
Input,
So-
output.
Yes. Y'all are all, I guess, in there somewhere. But y'all just wanted to be able to be on the video. But mechanical advantage basically is something that helps us to like make something easier, is like the easiest way I can explain it. Okay. So has any of y'all ever used a wrench before?
Yes.
All right. Have you ever had a bolt that you couldn't break loose?
Yes.
Did you get a bigger wrench then, a longer one?
Yes.
Or put a cheater pipe on it?
Yes.
Yes.
Okay. That's mechanical advantage, right? So like, for example, with my truck, a lot of times when I take the wheels off of it, I can't I have just a normal standard ratchet that I put on it. You know, it's about 1 foot long. And a lot of times I can't break it loose. So I put a 4-foot cheater pipe on it, and then I grab it at the end of the cheater pipe, and putting way less pressure is able to break. It makes it really easy to break the lug nuts loose, okay? Because I changed the distance. All right, I was 1 foot away from the lug nut whenever I was trying to put force, and then I changed it to about 4 foot away. And changing that distance caused me to have greater mechanical advantage, which made it easier to break the lug nuts loose, okay? And so that's something mechanical advantage does. Another way is they give me an example here with the little broom. All right, think about if you have a broom, because hopefully y'all have all sweat before. If I hold my left hand at the very top, and I put my right hand right underneath it, and I push that broom, okay? What do you think's easier, holding my right hand right below it, or holding it just a few inches further down? Down, right? Okay. It changes the ability, like how much force. So it takes way less force to push it at this angle or at this distance than it does from up here, right? Okay. So that's what they kind of show here. That 0.3 meters is like the mechanical advantage. So if I lower my hand further down, it increases the mechanical advantage and makes it easier to push. Okay. So keeping that in mind. Oh, I forgot to say that they have on this one 3 different formulas there. Okay. Mechanical advantage for lever, 2 of them for the lever, and then 1 of them for a ramp. All right, and when you're looking at the lever, you just got to tell, like, are they giving me force or are they giving me length? And just so you know, like on this particular worksheet, the force is measured in newtons. So you'll just put it in. The length is measured in meters. And mechanical advantage does not have a unit. Okay. So like on your worksheet or whatever, you want to make sure that you don't put a unit on if you're solving for mechanical advantage.
Right there. Oh, no.
Mm-hmm. Okay. All right. Next. So let's do an example. Number 1. A lever used to lift a heavy box has an input arm of 4 meters. So let's make note of that. Input arm, 4 meters. And an output arm of 0.8 meters. And just so you know, this is your worksheet, okay? So you don't have to like sit here and write out like all this because it's on your worksheet. Then it asks, what is the mechanical advantage of the lever? So I'm looking for mechanical advantage. They gave me the input arm and the output arm length. So we go back. Which one of these am I not going to use out of all 3 of these?
Bottom one.
The bottom one, right? The ramp. Because we're talking about lever, right? So we either got to use this one, the lever,
That one.
either this lever one or this lever one, right? Okay. Now, did they give me length or force? Length. So I've got to use this one. The mechanical advantage is equal to the Li over Lo, the input over the output. So let's write this out. So number 1, mechanical advantage is equal to lever input over lever output. Okay. Do we know what the mechanical advantage is yet? No, that's what we're solving for. So what letter do we use when we're solving for it?
X.
X. So let's put X for mechanical advantage. What's the input length?
8. No, 4.
4 divided by the output length.
0.8.
0.8. Put that in your calculator. 4 divided by 0.8. If it's a decimal on this worksheet, round it to 1 decimal place. 5 even?
5.
Okay. So mechanical advantage is 5. Do I use a unit if I'm doing mechanical advantage?
I thought the input was on the bottom.
Uh-uh. Input divided by output.
Oh.
So do I put a unit if I'm dealing with mechanical advantage? No. Remember, it doesn't have any. Okay, it's just 5. Questions on that one? All right, so number 3. Says a lever with an input arm of 2 meters has a mechanical advantage of 4. Then it wants to know what is the output arm's length.
So you need to divide 2 divided by 4.
Nope. Okay. So on this one, it's the same formula, right? Because we're dealing with the mechanical advantage of a lever again. So we're doing this one again. And we're doing the 2 lengths. So I'm going to do mechanical advantage is equal to Li over Lo. Do we know the mechanical advantage? Yes, what is it on this one? 4. It says mechanical advantage is 4. So I'm put 4 for it. What's the input? 2. And then what's the output? Unknown, so what do we put? X. Okay. Now we got to solve for X. Okay. So X is on the bottom. It's 2 divided by X. I need to move that X off the bottom to get it to the other side. So what do? So multiply it by X. Whatever you do on one side, you have to do on the other. So the left side, 4 times X is what? 4 times X is 4X. Okay. Then on the right side, what happens to those 2 X's?
Just turns to cancel out.
Yeah. They cancel or they go to 1, right? And then what am I left with? 2. All right, what's the next step? Solve for X. Divided by 4.
1/2.
X equals 1/2. What's that as a decimal?
0.5.
0.5. Do I have any units I need to put on this one? What am I looking for? What did I just find?
The output.
The output arm's length. Length is measured in what on this paper? Meters, right? Because the input was meters, the output's got to be meters. So it's 0.5 meters. Okay. Any questions on that? All right. Since it's a teacher made, make sure you put, if you're putting that, you'd put 0.5 space lowercase m for meters, okay? If it's newtons, if it's force, you would have said 0.5 space capital N for newtons. And just so that you're aware, this is just an extra one. If, say, I'm just going to make it up, say it was 8 is equal to you didn't know the input and the output was 4. How would I solve this one for X if it's like that?
8
8 times. Divided by 4.
So how do I get that 4 to the other side?
Oh, times by 4.
Times it, multiply it by 4, right? Because that's X divided by 4. So to get that 4 off the bottom, we multiply it to both sides. Those go away, so it'd be 32 is equal to X, right? Okay. So just because I know some of them work out like that one. All right. Now I want to show you one more. This is an example, so I'm going to show you. But take note on this page, some of them, they're going to want to use this work equals force times distance formula. Okay, so it's kind of like a 2-step problem. But number 8 here says we have an input force of 50 50 newtons, right? It's applied through a distance of 10 meters to a machine with mechanical advantage of 3. The work output is 450 newtons, so the work is 450, and it's applied through a distance of 3 meters. What's the output force? Okay. Now, I'm going to say some of these, they put a lot of unnecessary information. So, we can just stick with our normal formula, which says that mechanical advantage is, force, output force divided by input force. So this one right here, right? Because we're dealing with force. Output over input. So we can say output force over input force. Okay. And what did they tell me their mechanical advantage was on this one? When you read that, what's mechanical advantage? 3. We're looking for the output force, right? So what do I put for output force? X. And then what do they say the input force was? 50, right? That first one. Input force is 50. So how do I solve this one for X? Multiply it by 50, right?
Yeah.
So X equals 150. And that's my input force, right? So the input equals 150 newtons. Okay? You see how there was a lot of extra information in there? And I didn't need all of that? Okay. So I just pull out, if I can solve it normally, just use what I need to solve it normally. But sometimes we might have to calculate the force or calculate the distance or something like that, okay, to do so. All right?